everybody, welcome to another video. Hope you're ready to flex those brain muscles. Today we're going to learn how to convert a quadratic function from standard form to vertex form. So we're used to seeing these in standard form like this, right? Which is just ax squared plus bx plus c. That's what we're used to seeing these in. But now we're going to take some quadratic like this and convert it into vertex form, which looks like this. And there's a couple reasons why we do this. The first reason is because when we get it into vertex form, the vertex is easy to identify. We don't have to do any negative b over 2a and plug it back in. We don't do none of that. We can just look at it and see, okay, this is my h, this is my k, therefore that's the vertex. We don't do any algebra, so it's kind of nice. Second reason is sometimes it makes it easier to graph. It's a lot of times easier to graph, especially when we know transformations, right? When we can apply, different shifts and compressions and stretches and all that stuff, and we'll learn. I'll make another video on that stuff, but it can make it easier to graph. That's why we do this. So now we just got to learn how. How do I take something like this and make it look something like this? And the key to this is in this part, this x minus h squared. And this is just a binomial squared, right? Do you remember how we get from a trinomial to a binomial squared? We have to have a perfect square trinomial, right? We did this when we completed the square. I'll put the video up here. We solved quadratic functions by completing the square. So we had 0 on one side, and we had a quadratic, and we completed the square to solve for x. Now we're going to do something similar, except instead of having 0 on one side, we have y, and we're completing the square, not to solve for x, but to get from standard form to vertex form. So like I said, in order to get to some binomial squared, we can get there by factoring a perfect square trinomial. And I'll show you what I mean real quick. It would be better to probably click that video if you have no idea what I'm talking about, but just real quick. So this is an example of a perfect square trinomial, and I'll show you why. When we factor it, we're looking for two numbers that multiply together to be 4 and add together to be 4, which is just 2 and 2, right? So this factors into x plus 2 times x plus 2, which can be rewritten as, right, this equals this, which equals what? X plus 2 squared, right? X plus 2 squared. So that's why this is a perfect square trinomial. A trinomial that can be factored into a binomial squared, that's a perfect square trinomial. So if I can make this look like a perfect square trinomial, or at least part of it, then I can factor it down to some binomial squared. I may have a constant out in front, and I may have stuff added and subtracted outside of it, but that's fine. Those are both in my vertex form still, so we're good. So I need to just make this look like a perfect square trinomial. That's the key. So let's go ahead and do it. And again, there are different ways people do this. I'm going to show you the way I do it, but there's a few different approaches I've seen people take. But the thing I do is I get rid of the constant and move it to the other side. So I'm going to subtract 5 from both sides. Minus 5, and I'm left with y minus 5 equals x squared minus 6x. So I want just the stuff with x's by itself. I move the constant over. And now, do you remember the trick? We take half of b, we square it, and we add it to both sides, right? So what is half of b? That's negative 3, right? Because my b is negative 6. So I take negative 3 and I square it. That gives me 9, and I add that to both sides. So I'm going to add 9 to both sides. So I take, let me write that out. I take half of b, which is b over 2. I square it, and this is what I add to both sides. Add to both sides. Okay, so that's what I did here, and now I have a perfect square trinomial here. Well, let me do this algebra first. Negative 5 plus 9, that's y plus 4. So I got y plus 4 equals x squared minus 6x plus 9, and we'll confirm that this is a perfect square trinomial by factoring it. Two numbers that multiply together to be 9 and add together to be negative 6. That's negative 3 and negative 3, right? So this actually factors into, and I still have the y plus 4. Hopefully y'all can see down here. So this factors into, what did we say, negative 3 and negative 3. So I have x minus 3 times x minus 3. And you probably could have just gone right into x minus 3 squared, and you would have been correct, right? X minus 3 squared. But this isn't my answer, because in this form I have just y equals. So now I need to get the y by itself. I have y plus 4 equals x minus 3 squared. So what do I need to do? Subtract 4 from both sides. And that's what you'll almost always have to do at the end of this. So let me see, I'm gonna move my final solution up here since I have room. I got rid of the 4 there, now I'm just left with y. I have y equals the x minus 3 squared minus 4. X minus 3 squared minus 4. So what is the vertex of this quadratic? Let's look. H, and since we have minus h, my h is 3, not negative 3, right? So vertex is what? 3 comma negative 4. This is plus k, negative 4. Hopefully y'all can see that. Okay, so now we have an example, but in this case, our leading coefficient is not equal to 1. So this is where a lot of students make mistakes because it gets a little tricky. So we're going to go ahead and do this example. But I still start the same way. I still move the constant over. I want just the stuff with x's on one side. So I'm basically going to subtract 170 from both sides. Minus 170, minus 170. And don't let these big numbers scare you. So I have y minus 170 on this left side equals 2x squared plus 36x. So this is when it gets a little tricky. If you watch my video or if you remember how to complete the square, we have to have 1 here, right? And when we don't, we divided both sides by actually whatever this was in order to get 1. That's what we did when we solved quadratics by completing the square. We divided both sides by whatever was out in front. So in this case, we could divide both sides by 2 and that would work, but what we usually do is we just factor the 2 out, right? Because these both share a common factor of 2. I could factor the 2 out and I'm left with what? X squared plus 18x. Right? And now if I could just turn this into a perfect square trinomial, then I could factor this into a binomial squared. This out here is just my a. I have my binomial squared here, and I can just move whatever this is back over, and that's going to be my k. So this is what we normally do, and this is normally how it's taught. So this is the way I'm going to do it. So I still have this y minus 170 over here. Okay. So now, again, same thing, b over 2. So half of this value, 18 divided by 2, that's 9. I square it, that's 81, and that's what I add to both sides. So I'm adding 81 in here. But this is the key. We need to be really careful. I added 81, so this is where the mistake is normally made, is they'll say 81 and they'll add 81 to this side. But what did I really add to this right side? I added 81 within these parentheses, right? And everything in here is what? It's being multiplied by 2. So what I really have to add to this side is 2 times 81. So just make sure you notice that and be careful. And as long as you're careful, then you're good. So 2 times 81 is what I have to add to this side. Plus, what is that, 162? Hopefully that makes sense because I added 81, but that's within these parentheses. This is all being multiplied by 2. So what I really added to this right side is 162. So I have to add that same thing to the left side to balance my equation. So now I can simplify this. Minus 170 plus 162, that's y minus 8. So I'm going to write that down here, y minus 8. That's what I have on the left-hand side. I have my 2 out here, 2. What am I left with in here? Well, remember that b over 2, that was 9. And there's a trick. Remember that 9, that half of b, is always what's in here, in the binomial squared. So that's a little trick. And if you don't remember that, you look for 2 numbers that multiplied together to be 81 and added together to be 18, and that would give you 9 as well. But that is a little trick. So now I just need to solve for y, add 8 to both sides, right? So my final equation that is in vertex form, let's see, I have y equals 2, make sure that's a 2, sorry about that, 2x plus 9 squared. Let's see, I added 8 to both sides, right? So this is plus 8. Okay, so that's my final quadratic equation in vertex form. So what is my vertex? Vertex is what? It's not 9, negative 9, right? Because we have minus h, negative 9, 8. There we go. Okay, so real quick before I wrap up the video, I'm going to use the same example and we're going to make a connection from the last video to this video. So in the last video, we found the vertex of quadratics just in standard form using this negative b over 2a, and then we plugged it back in to find the y coordinate, and that was our vertex. In this video, we converted to vertex form in order to find the vertex and graph ultimately. But there is another way to convert to vertex form other than completing the square, and I'll show you how right now. So if we can find the vertex using this negative b over 2a, and then plugging that back in and finding f of negative b over 2a, this is our h, this is our k, and this leading coefficient is our a. We have a, h, and k. All we're left with is x and y, which just stay x and y, right? Those are our variables. So we can convert from standard form to vertex form just by using this negative b over 2a stuff. So let's go ahead and see how this works. I'm going to do negative b over 2a of this, and that is what? B is 36, so I have negative 36 over 2 times a, that's 4. This equals negative 9, and that's exactly what I got when I completed the square to do this, right? Negative 9. But now I got to plug negative 9 back in, and this is the one disadvantage, is that sometimes you get really ugly numbers. But I'll go ahead and do it. Negative 9 gets plugged back in. That's 81 times 2. That's 162 plus 36 times negative 9. What is that? So it's going to end up being minus because it's negative 9. Minus, let's see, 36 times 10 is 360. Minus 36. That is what? 324. 324, is that true? I hope that's true. Plus 170. So now I'm going to simplify this, and we can prove it's true. If we get 8, if this gives us 8, then I did my math correctly. So 162 plus 170, that's 332. Minus 324 gives us 8. So now I have my x-coordinate of the vertex, I have my y-coordinate of the vertex. So I've proven that the vertex is negative 9, comma 8. And since I have these two values, I can plug them in for h and k. And my a is always just this leading coefficient. So that's another way you can convert from standard form to vertex form. Maybe you hate completing the square and you want to do it this way, then you can, unless of course your instructor asks you convert to vertex form by completing the square. If they're specific like that, then you have to do it that way, but it's good to know both. They're both kind of fun ways to do it, and yeah, hopefully this video helped. If it did, hit like below. Check out my channel for more videos, more knowledge, and more brain gains. See you next time.